Hello, I'm Stephanie Boluris, your host for Forrester's podcast, What It Means, where we explore the latest market dynamics impacting executives and their customers. Today, we're joined by Vice President and Research Director and my good friend, Glenn O'Donnell, to discuss how the ongoing chip shortages could impact your AI plans. Welcome, Glenn.
Thank you. Great to be here again.
So one place that I actually want to start is on the chip shortage itself. I think some people might be surprised to hear that there's a chip shortage. Maybe set some context about why there's a chip shortage and where it is specifically, because based on conversations we've had and also the research that's about to come out, it's really about the type of chip where there's a shortage.
Yeah, exactly. And for a while, we did have a chip glut. And what happens is, the semiconductor market rides the wave of the general economy. So, during the pandemic, for example, everybody was out there buying new PCs. So there was a big demand for PCs. And everybody, what happened was we needed more chips, and we wound up having a chip shortage. And, after that, we had what I keep calling the hangover. The economic hangover, where the economy went into the tank, and people weren't buying new PCs because they already had a new PC, and a lot of other products that needed chips kind of went on the back burner. So, the supply was still there, but the demand had dropped, and therefore we wound up with a bit of a chip glut. And that's turning around now because demand is returning, and we have a lot of other factors playing into this. But the main reason that demand is returning now is all this craziness about AI and how that's exploding. But we also have geopolitical issues that have come into play that are changing the landscape. And now there's just more demand for technology in general. We see that returning pretty aggressively. So the glut is over. But you mentioned that some chips more than others. I like to talk about this bifurcation of the market where we have high-end chips, and this is the stuff that gets all the attention, right? This is the GPUs from NVIDIA and the microprocessors from Intel and AMD. That's the advanced stuff. We talk about, advanced manufacturing. And yeah, that should be getting a lot of attention. But there's a long tail of other chips, these little chips, small microcontrollers and sensors and analog chips and so on. These are cheap chips. They're small chips, and we need an awful lot of them. That demand has been around, has been strong throughout this period, and that did not suffer any kind of, deficit as we went along. So we've always had a chip shortage on those chips, and that's still continuing.
Okay. So the chip shortage we're talking about now really is on those high-end chips that we're talking about. Yeah. And,
yes.
And like you said, it is cyclical. It depends on the economy and how much, IT buyers are buying core infrastructure, and the hyperscalers, I imagine, as well. So, and we have covered this issue in the past. What's different now, this time around, with this particular shortage?
Well, you see more demand around AI, and it's not only creating demand for, say, NVIDIA. NVIDIA is the hottest thing in the world right now.
Right.
And it's a $1.2 trillion company, which is just kind of crazy. But that's been getting all the attention, as well as the other large chip makers have been. But you also have the cloud players. You mentioned them. They're building their own chips. Microsoft recently announced that it has its own chips for doing AI workloads, and that's powering its new Copilot services and such. So there's just a whole lot more diversity in the marketplace as far as what kind of chips. Apple famously started making its own chips, and the Qualcomm processors are starting to show up in more devices. So it's no longer a vanilla kind of marketplace, but it is AI, and more specifically generative AI, that is driving the demand right now. And of course, all the chip makers want to play that, and all the products that the chips go into, the Dells and HPs and HPEs and Lenovo's of the world, for example, are all trying to position their products as being AI ready. But that means you have to buy new products that require new chips.
Okay. So the AI explosion is exacerbating it.
Yes.
Then you also hear about new fabs being built. So chip makers are adding capacity, but how quickly is that capacity coming online?
It's taking a while because, number one, it takes a long time to build one of these fabs, one of these manufacturing facilities. They're massive facilities. They're very, very complex. They require a lot of equipment that is not easily acquired. So, for example, there's so-called photolithography machines that are necessary. And for the advanced chips, there's only one company in the world, ASML, out of the Netherlands, that makes those things. So, they can only make so many machines, and you have to put these into the fabs. So it takes a long time to build these things. And it's been delayed partially because of the economy, partially because of their own supply issues like ASML. And we're finally starting to see some of that come together, but it's still going to take a while. They only broke ground recently on some of these things, and we won't see a serious material impact until 2025.
And then talk a bit about the geopolitical issues as well. I mean, that's another thing that everybody reads about in the news every single day, which is the U.S. is putting curbs on specific chips that might be sold to China to curtail some of their ambitions in AI, particularly AI that might be used in a military context.
Yeah, so you do see a lot of that, and in fact, the CHIPS Act, which is a big piece of legislation that passed here in the U.S. some time ago, is mainly aimed at that topic. Now, some people will say, well, the aim of the CHIPS Act is to diversify the supply chain. And yes, that is true. But the main issue is the U.S. government wants chips to be made in the U.S., not to be made in other countries. And they've got all these incentives for the chip makers to build facilities here in the U.S. And the European Union has similar legislation and similar incentives to bring things there. That's going to certainly help with the supply, because we'll have more fabs and they will be more distributed, and that supply chain will be more resilient because of that geographic diversity. But it's in the meantime, the trade war is complicating things for the chip makers. So, for example, NVIDIA, we've been talking about, it's been restricted on what it can sell to China because, China can use those chips for military purposes. That has impacted NVIDIA, but, don't shed any tears for NVIDIA. It's got demand elsewhere.
Getting back to the chips, and we kind of talked about the distinction between the low-end chips and the high-end chips. And really, we're talking about shortages or supply chain pressures around the high-end chips. But even within the high-end chips, we're talking about specialized chips now, right? You might have high-end chips for, even high-performance computing, but then chips are being designed specifically for AI workloads, being optimal for AI workloads. So maybe we could talk a little bit more about, again, the impact AI specifically on this issue of the chip shortage.
Yeah, certainly. And again, everybody talks about NVIDIA as being synonymous with AI.
Right.
You got this word association. I say AI, you say NVIDIA. It's almost a knee-jerk reaction. But, NVIDIA's products, they're great products, and it's a great company. But the GPUs are still general-purpose devices. They're not optimized for AI. They certainly are better at it than a standard CPU that you get, an x86 type CPU from Intel or AMD. But it's still a general purpose device. And what you see now, especially with the cloud players right now, making their own chips, and they're optimized for whatever they're trying to do. So Google has its TensorFlow algorithms and its tensor processor optimized for those algorithms. And you're going to see more of that. And Microsoft is the most recent entry into that field. And as this plays forward, you're going to see more and more of this customization of the chips. And not just by the big tech giants. Eventually, you're going to see that play out in all kinds of companies where you will have customizable chips.
And when we think about the outlook, right, we do know that new manufacturing facilities are coming online. There's a diversity of players now that we never had in the past. But I think what we're predicting, though, is that in the short term, at least for the next couple of years, or maybe less than that, um, there is going to be some limited chip availability. And
Yes.
okay, yeah. And what exactly is that time frame? Like, how long do we think this shortage will last?
Well, we're going to continue to have a drought throughout 2024. And probably early to mid 2025 is when some of this manufacturing capacity comes online in a meaningful way. We will see incremental improvements throughout 2024, but it's not going to be until some of these new fabs come online that Intel and TSMC and some others are building. That's when you'll see the capacity finally catch up, and that's when things will really settle in. So that's the time frame we're looking at, and we'll see it continue to improve because more fabs will come on during 2025 and 6 and 7 and so on.
Okay. In the short term, I mean, when I think about AI and specifically like generative AI, companies are really just embracing it now and piloting it now and looking for different opportunities in everywhere from customer service with chatbots to employee productivity and maybe using AI to like amplify and drive some insights into the organization. What do we think will be the impact of this? Like, how much do we think it'll temper some of the ambitions that companies actually do have around AI? And is that different for your average enterprise versus what the hyperscalers might be experiencing?
Yeah, that's a good point. There's so much enthusiasm around AI right now, but there's only so much you can do. So the ambitions for AI are unlimited, but the capability to pull off those ambitions has indeed hasn't hit a wall, but it's kind of brushing against that wall right now. And that means that people are going to have to be more pragmatic and prioritize what they're going to try to do. And that applies to enterprises, but it also applies to even to the cloud providers. You think these cloud providers have absolutely unlimited capacity. Well, they don't. And they're struggling to get enough chips, whether they're NVIDIA chips or their own chips. Again, there are only a few companies in the world that make these chips. So, they have limitations. So everybody's going to have to kind of settle down and be more pragmatic about what it is they're going to do with AI in the future.
The cloud providers, I mean, it's interesting. I imagine because of their heft, do they use that to create priority for themselves with some of these suppliers and have some of them knowing that there's a shortage, knowing that there's such demand, like have they also been buying up a whole bunch of chips?
They have been buying up a lot of chips. They've been stockpiling,
Yeah.
and even you see a lot of that in China, where the Chinese companies have been stockpiling because they see that, all right, we're not going to be able to get these chips in the future, so let's buy up a zillion of them right now while we can. But eventually that is even going to peter out at some point. We're gonna run in. We're going to use all that up essentially. So I don't see that. I don't see that. Until we get more capacity, that we're really going to relieve that tension. Yes, the cloud players, because of their size, they do have enormous purchasing power. But you can't get blood from a stone. If they need more chips, you're just not going to be able to get them.
Okay. So if we were to give advice then to CIOs, other tech leaders about this, like what can they do?
Prioritize your AI ambitions. Again, everybody gets all excited. Oh, we're gonna use AI for this, and we're gonna use AI for that, and everybody's just going crazy about it. And the craze is understandable. It's exciting. It's powerful. But if you could only pick three things, what three things would those be? instead of the 20 or 30 that people may be coming to you to deploy, because it's going to be easier to focus on those three, and it's going to be easier to get the capacity for those three that you want to do.
Yeah.
So prioritize.
I'd also imagine that's not necessarily a bad tech strategy either, right? Rather than trying to do 20 things, do three things that you're really passionate about, meaning that it's going to have a huge impact for your business or your organization, whoever it might be. Pilot those, gain the experience, and then in 1 to 2 years, as the capacity comes online and the supply chains start to ease, then you'll have the ability to then buy and be ready to really, really go full scale.
Yeah, you're exactly right. This is nothing new. We've seen this whole thing play out before, where everybody goes crazy over some latest shiny object, and you got to prioritize. You can't do it all.
Yeah. But back to the competition. I mean, now that we actually do have multiple chip makers, for example, like we were just saying, um, there's new processors incorporating circuitry aimed at improving AI processing. Um, how has like Microsoft's entry into this changed the competitive landscape, and how does that impact the CIO? Like, what does that actually mean for the CIO?
Well, one thing it means is, NVIDIA has had a stranglehold on this marketplace, and it's going to continue to be the big dog in the fight. No doubt, it's a massive force. But what you see here is Microsoft, Google, AWS, other cloud players, and even other tech players like Apple, kind of chipping away at that complete stranglehold that NVIDIA has on the AI marketplace. So it's probably going to take a little bit of the shine off of NVIDIA. But for CIOs, it means that you have more choice, and you have some more, looking at the services from Microsoft, they are going to be optimized for what you want to do. It's going to be purely aimed at things like Copilot, as opposed to general purpose AI, and running some of the open AI algorithms and such that have become part of Microsoft, even beyond just the Copilot.
That's also important. Like, as we've been talking about, these chips are being designed specifically for hooks into AI and improving their processing and other results. That's a change, right? I mean, I think it's been a long time since we even talked about the importance of chips. I think for a long time, people that just thought of it as something completely commoditized. So that's a big shift. So I don't know recently if I can think of a time when CIOs really thought about the chip in any of the infrastructure that they were purchasing.
Yeah, and in fact, we here at Forrester, as you're well aware, we haven't really, in the past, we hadn't done much on chips because, well, it was kind of a boring marketplace. There wasn't a whole lot happening beyond a couple of the leaders, and everything was running on these general purpose devices because it could. But now, as we see the changes in things like AI or other application-specific needs, we need more power, and we need more power per watt. And this is something that's important to consider: is how efficient can these chips be? If you got a chip that's doing everything, a general purpose type of device, it's burning a lot of power doing things that you don't need it to do. But so you have the efficiency issue, and then you also have of course, the optimized functionality. Yeah, in the past we could look at it and say, kind of compare it to the automotive industry, where, okay, everybody's getting an SUV. Well, what if you want a sports car? What if you need to haul big quantities of dirt? There are specialized vehicles to do that, and just as we have in the automotive industry, we need specialized vehicles to run these various workloads.
Okay. So that's new then. So really, it's not just the economics, but now it is the technology itself has to really, CIOs really have to take it into account when they're developing their tech strategy. Well, maybe not their strategy, but their architecture, certainly.
Yeah, and CIOs don't necessarily buy chips themselves.
Right.
They buy products with chips in them, so they have to go to their suppliers. They have to go to Dell and to HPE and tell them, hey, we need a certain capability to do this or that, and it's up to them to supply that capability. And you're seeing some of that now with the partnerships that those companies have with NVIDIA, but also what you see coming from AMD and Intel as far as additional capabilities that they're putting into the chips. And each of these system players that CIOs do buy from, they're forming these partnerships and they're diversifying their own product line, but they have not yet gone the path of optimized processors. At some point they will, but they haven't yet. And there's really no way for them to do this at scale yet. They will in the future have the capability to have chips that will be programmable. And I think that's when you'll see this really take off, but that's several years away. In essence, you reprogram the chip to do what you want it to do, and it'll be optimized for that. Even though it's, you and I have the same chip, but we've programmed it to do different things.
Interesting. Okay. So we've talked about, moderating your AI ambitions, or maybe even taking an advantage of this time to just focus and pilot and learn some lessons and best practices. We talked about the importance of really thinking about the hooks that the chips now have into AI and how that impacts your tech strategy. And it sounds like potentially who you partner with in your vendor selection. Any last recommendations for CIOs and tech leaders?
Well, I touched on the efficiency and sustainability factors, which is driving a lot of this as well. And CIOs have to take a serious look at their sustainability, their carbon footprint, because technology itself consumes a lot of electrical power. It has a big carbon footprint, and these chips, especially the general purpose chips, burn a lot of power. This high-end NVIDIA processor burns 700 watts. That'll heat a small room. More than a small room. That's a decent space heater. And you need a lot of these things. The cloud providers are buying them by tens of thousands. And we need a more efficient way of doing this. So having a chip that's optimized to do what it needs to do, no more, no less, means it's going to burn less power, generate less heat. And that's a trend that you're going to see play out pretty heavily over the next few years. And the CIOs have a fundamental responsibility to drive a lot of that initiative.
Yeah, it's interesting. According to our own data, the role of IT in a company's Scope 1 and Scope 2 emissions is as much as 20 to 25% of their emissions. Yeah. And then actually in some industries like financial services, I've seen it as high as 55%. So yes, it's a huge, huge impact.
Yeah, and you can't just pawn this off on the cloud providers and say it's their problem, not mine, because that is your Scope 2 emission. It's still your responsibility because you're the one burning the power to do what you need it to do.
Yeah. Well, actually, in that case, it would be Scope 3, but it's still
Scope 3.
Yeah, it'll be your Scope 3 for sure. Well, fantastic, Glenn. That's some great advice, and thank you for joining us.
Yeah, thank you. It's always a pleasure.
If you like what you heard today, subscribe to Forrester's What It Means podcast on Apple Podcasts, Google Podcasts, or your favorite podcast player. To continue the conversation, follow Forrester on Twitter, Instagram, and LinkedIn, or drop us a note at podcast@forrester.com. Thanks for listening.